All right, so this video is going to be to review for your upcoming final exam, and we're looking at the review questions, the supplemental materials, and the self-review test questions from the book for Chapter 9. So the first question that the professor wanted you to look at was question 9.73, and it said that there was the mean consumption of water in a city is 1,245 cubic feet per month for each household. Okay, and then there was a campaign for water conservation. And so we have a random sample of 100 houses, and that had a sample mean, label that as X bar, sample mean of 1175. And we're going to do this under the assumption that the population standard deviation is 250. Since I know the population standard deviation, I can use the Z distribution. Okay, find the p-value for this hypothesis test and draw the conclusion. All right, so in the question, and I don't think I wrote it here in my notes, but in the question it says like, hey, did the water conservation stuff help? So if my current center is 1245, do I have significant evidence that 1175 is so much lower that like, hey, this campaign actually helped and the mean is actually now lower than 1245? And so what that means is our null hypothesis is going to be 1245 and our alternative hypothesis is going to be less than. That's what we're testing here. And so we're going to do a Z value. So Z is equal to 1175 minus 1245 all over the population standard deviation over the square root of n. If you plug this into your calculator, okay, you get negative 2.8. Now, if we look on, it wants us to use the p-value approach first, okay, and then we'll also do the critical value approach. So I'm looking on my t-chart and I'm looking under the infinite row here because that's actually your z-chart. It's a little bit of a trick, okay? Now, another trick that we need to look at on this question is this is only, your t-distribution is only your right-hand side. So we're going to look at this in absolute value, okay? So 2.8 is going to be between these two critical values. And so if I go up here, that means that my p-value must be between these two here. So that gives me 0.001 and 0.005 as my bounds. Now that is very small. Okay, that's a very, very, very small p-value. And so that's going to lead me to reject HO. Here. Now, if you wanted to do this in your calculator, you definitely could. Okay, so we'd go to stat, test, this would be a Z test. Okay, and we'd go ahead and plug everything in that we know in order to run the program here. We're doing a less than, and we tell it to draw. Okay, and then it actually finds the exact p-value for us, which is correct. 0.0026 would be between 0.001 and 0.005. So we did the correct answer here, and we would reject HO. Now, part B says, hey, use that critical value approach. Okay, so in this question here, I'm going to do this under, I don't think I wrote what alpha should be. So let's just do this under alpha is 0.01 just for funsies, okay? So if I look under alpha of 0.01, on the right-hand side, that would be 2.326, which means on the left-hand side, that would be negative 2.326, okay? Negative 2.8 is smaller than that critical value, and so I would be able to reject. I would be in that rejection region, okay, and so yes, I would reject HO. All right, 9.75. A real estate agent says that the mean of houses in this city is at most 2,400 square feet. We have a random sample of 50 homes, and that sample had a sample mean of 2,540 square feet, and then a standard deviation of 4.72. Now, since this is S, I'm going to have to use the t-test here. Okay, I don't know the population standard deviation. I'm going to have to use S for that approximation, which means my variability is too high, so I need to use the t-test here. Use the critical value approach at this alpha level. All right, well, let's write our hypotheses first. So our center of our distribution is this claim of 2,400, and what I'm trying to prove with my sample is that it's actually bigger than what the real estate agent seems to think. And so if I'm using 0.05, here's my HO, I'm doing a right-tailed test where this is all 0.05 over here. I'm going to look up that critical value, and I'm going to get 1.645. Okay, and so as long as our Z, or T actually, that we're going to try to find, as long as it's bigger than 1.645, then I have significant evidence here. Okay, so let's go ahead and calculate that T. So T is equal to X bar minus the mean all over S over the square root of N. And let's look here. So 2,540 minus 2,400, divide that by this, and I get 2.097. That is larger than my critical value. I am outside that bound here, and so I have significant evidence to reject HO. Now the next part of this question is like, hey, what if I change my significance level to 0.01? Well, let's look at what that critical value would be for 0.01. That critical value, if I look it up in the chart, is 2.326. Well, in that case, my T is not greater than the critical value. So in that case, I would fail to reject HO. So knowing your significance level could be really, really, really important as to your conclusion, because as you can see here, if you choose a different significance level, you might be able to report your data in one way or another based on just what that significance level is going to be. All right, 9.77. There is a claim that the wait times average is 25 minutes. There is a random sample of 16 patients, and we just want to know, is the mean actually different from 25 minutes, and use the critical value method is what professor wants us to do. So what we want to look at here is, let's look at this alpha first. 16 patients, we do have a degrees of freedom that we want to look at. Okay, so average is 25, and my degrees of freedom for this T distribution is going to be 15. Okay, so let's go ahead and look at that here. 9. Oh, sorry. Alpha and and is different from. Let's also do that. 0.005 on each side. Let's see what that critical value is. Okay, so I go under my T distribution. I need to go under 15 degrees of freedom and over to the correct here. So plus or minus 9 or 2.947. 2.947. All right, let's set up these hypotheses here. So our null hypothesis is 25. Our alternative, all that I want to prove here, is different from. Okay. And let's find that t value. So t is equal to 27.5 minus 25 all over 4.8 over the square root of n. And we can calculate that here. Okay, so let's compare that. 2.6 is not in my range here for my critical values, okay? It is not larger than this value here, so I'm going to say this is less than my critical value boundary, and so I'm going to fail to reject. Okay. Now we're going to look at some proportions here. So we're going to go back to our Z distribution because we're looking at proportions. Okay, 75% of adults in the study said that meeting basic needs is very or extremely important in the vision of the American dream. There's a random sample of 1,500 adults and 72% agree with that statement. So the first thing that I'm going to do is I need to know how many people is that. Okay, that's 1080. So X is 1080. Okay. Using the critical value approach and an alpha of 0.01, is opinion actually less than 75%? All right, well, let's write our hypotheses here. So P equals 0.75. I'm trying to test here, is P less than 0.75? And I'm going to use the critical value approach. Since it's a left-sided test, all of my 1% can go on that left side. Let me look this up in the chart. Okay, negative 2.326. Okay. All right, so if my value for Z is less than, my critical value, less than that value, then I have significant evidence here. So let's calculate it. So Z is equal to 0.72 minus 0.75 all over 0.75, 0.25 over N. Now, in confidence intervals, we would have used p hat here for the standard deviation, but when you have a normal model that is set at 0.75 here in the middle for that p, you're going to use that for your standard deviation, okay? So use the population proportion if ever known. Okay, and I get negative 2.68, which is less than my critical value. It is outside that bound, so I reject HO. Okay, and then part C says calculate the p-value. Well, if I want to look at the p-value, this is my critical value. I am going to use the infinite strand here. And 2.68 is going to be between 2.57 and 3. So I'm going to say that my p-value is just somewhere between 0.001 and 0.005. Okay. Now, I could do this in the calculator as well and find the exact p-value. So if you go to tests, and it's one proportion Z test is what we're running here. 0.75 is my center. 1080 is my X out of 1,500 adults. We're running a less than test, and you can just press calculate or draw either one, okay? And you can see 0.0036 for my proportion here, or my p-value, sorry, is in between 1 and 5. That makes sense, okay? All right, a few more questions here. 75% of people had cell phones that were smartphones in 2014. There's a current sample of 1,000, and they found that 790 now have smartphones. Is this different from the 2014? Okay, so HO is P is 0.75. And I'm trying to test, is it different from 0.75? If I want to use the critical value approach, alpha of 0.02 means I have 0.01 on either side. And 0.01 has a critical value of 2.326. Okay. All right, let's go ahead and find our Z here. So Z must be equal to, well, 790 out of 1,000 would be 0.79 minus 0.75 all over 0.75, 0.25 all over N. All right, let's go ahead and figure this out. Okay, and that gives me 2.92. That is outside of my critical value range, so I'm going to reject HO. Okay. We could also look at the p-value range. The p-value range is going to be pretty low. You could also look at running a one proportion test here. So 0.75 still 790 out of 1,000. And we're doing the not equal to test. And it will give you your p-value here. And you can check to make sure your Z is correct, which our Z was definitely correct. All right, there are also a couple questions here from the self-review test, okay? So on number 16, it says U.S. workers paid an average insurance premium of $1,170. Okay, that's for a single person. A random sample of 100 workers had an average of 1198. And then in this one, it gives us the population standard deviation, okay, of 125. So under the alpha of 0.05 and using the critical value method, is this significantly different? Okay, so HO and I just want to figure out, is this significantly different? If I have an alpha of 0.01, then I need to share that on either side. So 0.005, 0.005, just like so. Okay. And then I need to calculate what that critical value would be. So that critical value would be plus or minus 2.576. All right, let's go find that Z-score and compare it here. So Z is equal to 1198 minus 1170 all over 125 over the square root of N. 2.24. Okay. Now when I compare that here, it is not there. I am only here. Okay. I'm not far enough away. And so I'm going to fail to reject. On part B, it wanted us to look at the critical value of 0.025 and think about, is it significantly larger? Okay, so all of that alpha is now over here. And that changes my critical value to be 1.96. Well, in that case, Z is now in that rejection region here, because 2.24 would be inside that shaded region. So in this case, we would reject HO. Okay. All right, let's run this in the calculator to get the p-values here. So I'm running a z-test, 1170, 125. Here's my mean. And 100, and let's run the not equal to first. Okay, so that p-value of 0.025 is not less than my alpha level, so that's why I did not get a significant evidence rejection here. Versus if I run here and do the larger than, okay, my p-value gets smaller because now I'm only looking at this one side here, and it is smaller than alpha, and so that's why I can reject HO under those conditions. Okay, so setting the conditions up early is really, really important, and understanding what the question is asking and what you're trying to prove, okay, can make or break whether or not you have that significant evidence or not. All right, 2 more questions here that we're going to look at. Baseball games averaged 3 hours and 5 minutes, which is 185 minutes. They have a meeting about it, 36 more games, and the mean goes down a little bit. Okay. Do we have significant evidence that game times actually decreased? Okay. So in this, do game times actually decrease? So null hypothesis is that 185. Do I have evidence that all game times have actually significantly decreased? Let's use our critical value method to test this. Okay, so that critical value for 0.01 would be negative 2.326. Let's calculate. Oh, actually, I need to account for degrees of freedom here. I need to look under 35. 2.438. Okay, because this is going to be a T, not a Z, because I know S. All right, so that's now all correct. Okay, so 179 minus 185 all over 12 over the square root of n. I get negative 3. Okay, negative 3 is inside my rejection region. So I'm going to say, since this is less than my critical value, that we have enough evidence to reject HO, which is great. Okay. All right, last question here. The mean time to write a textbook is at least 31 months. A random sample of 16 authors wrote their books with an average of 25 months. Okay, a standard deviation of 7.2 at this alpha level. Is this claim true? So the claim is that it takes at least 31 months. Based on this data, I think that it actually could take less. Okay, so let's use that alpha level of 0.025 to find our critical value. Now our degrees of freedom are going to be 15. I don't want to make that same mistake twice. So I'm going to look under degrees of freedom of 15.025 would be negative 2.131. Okay. All right, let's go in and calculate t now. So 25 minus 31 all over 7.2 divided by the square root of n. And that is in my rejection region here, so we can reject HO. Okay. All right, and that just about does it for chapter 9. I hope this was helpful and helpful for you to study for these types of questions that are going to be on your final exam.